Hello class 10. Today's topic is latent heat and specific latent heat. So let's learn about latent heat. So let's say that there is a unit mass solid. Let's say that the solid is of unit mass. That means it is 1 kg or 1 gram. So if the solid has the mass of 1 kg and if it is heated, then the temperature will increase as we have learned earlier. Then at a certain temperature, the temperature won't change, it remains fixed, and then the change of state takes place. So, in other words, we can say that after increasing the temperature for a certain time, the heat applied will be required or heat applied will be used in order to change the state of solid to liquid. That is, solid melts to liquid by taking that amount of heat without changing the temperature. This heat energy absorbed by the solid during melting without any change in temperature is called latent heat of fusion. In this case, it's melting, that is why it is latent heat of fusion. Similarly, if we take a liquid with a unit mass, let's say the mass of 1 kg liquid, and if it is cooled, then the temperature will decrease first, then reaching a certain temperature, the temperature remains fixed. So at this time, when the heat is getting liberated, means when it is coming out of the system, then the change of state will take place, keeping the temperature fixed. So we can say that the heat energy which is liberated by the liquid during freezing without any change in temperature is also the latent heat, but this case it is the latent heat of freezing. So now we know that different material has different latent heat. This is because different materials have different kind of properties. So this different material with different latent heat, this latent heat will be called as the specific latent heat. So the specific latent heat of a substance at any state, maybe it's liquid or solid or gas, is the quantity of heat energy absorbed or liberated by the unit mass of the substance for the change in its state at a constant temperature. So we can say if a solid of unit mass changes its state by absorption of heat, then that will be the specific latent heat of that particular substance in that particular state of matter. So the specific latent heat is represented by capital L, which will be equal to the heat energy Q divided by mass of the body. So L is equal to Q by M is the relation between the specific latent heat, the heat energy, and the mass of the body. The SI unit of specific latent heat is equal to joules per kg. We can see from here only that it is heat per mass, that is joules per kg. Similarly, the other units of specific latent heat is calorie per gram and also kilocalorie per kg. If you need higher units or bigger units of specific latent heat, then we'll use kilocalorie per kg. Now let's understand it for the case of ice. Let's say that there is an ice of mass 1 kg. Then the specific latent heat of this ice, that means the amount of heat energy required to melt 1 kg of ice completely at 0 degree Celsius, will be 336,000 joules. So 1 kg of ice at 0 degree Celsius absorbs this heat energy of 336,000 joules to melt into 1 kg of water at 0 degree Celsius. Or similarly, we can say that 1 kg of water, in order to freeze at 0 degree Celsius to form ice, it will liberate 336,000 joules of heat energy. Next is the natural phenomena involving latent heat. Snow on mountains does not melt all at once because the heat energy required for ice to melt is quite huge. So, snow cannot melt all at once because it will require a lot of heat energy to melt. So, sun's heat energy is not sufficient enough to melt all of ice from the mountains. Next is water in lakes does not freeze all at once. Again, because the latent heat required for lakes to freeze is again required. So water in lakes, they take time to freeze. It will freeze, but it will not freeze all at once. When ice starts melting in frozen lake, the surrounding becomes very cold. This is because in order to melt, ice from solid state to liquid water, it will take the heat from the surroundings, and that latent heat will be absorbed from the surrounding, making the surrounding cold. So this is the reason the surrounding becomes very cold when ice starts melting in frozen lake. Similarly, it is more colder after a snowfall than during the snowfall. Again, it's the same reason, because once the snowfall takes place, at that moment when the snowfall is happening, the temperature does not drop that way. Means the heat is not lost, but once the snow starts melting, it will start absorbing the heat from the surrounding, and then the surrounding will lose the heat energy and start becoming colder. So it becomes more colder after the snowfall takes place. Ice is added to the drinks, which cools more quickly than by adding water at same temperature. This is because 1 gram of ice takes 336 joules of heat energy from the drink. But when water at 0 degree Celsius is added, it cannot liberate heat energy of 336 joules, because ice, because of it, the latent heat of ice is 336 joules in order to melt. So it will absorb that heat from the drink, and it will make the drink more cool. Next, we'll look at some of the numericals. So here question number 1. 10 gram of ice at 0 degree Celsius absorbs 5460 joules of heat energy to melt and change to water at 50 degrees Celsius. Calculate the specific latent heat of fusion of ice. Specific heat capacity of water is 4200 joules per kg per Kelvin. So let's try to understand the problem. Here we'll first write down whatever data has been given in the question. So specific heat capacity, we write it as small c, is given as 4200 joules per kg per Kelvin. The heat energy that has been absorbed by this ice is 5460 joules, and the mass of the ice is given as 10 grams, which we converted in terms of kg becomes 0.01 kg. Now, according to the question, it has been mentioned that we have to calculate the specific latent heat of fusion of ice, and the mass of 10 gram of ice after absorbing 5460 joules of heat energy gets melts down and changes to water at 50 degrees Celsius. So over here we can say that amount of heat energy required to raise the temperature of water. First we'll consider water from 0 degree Celsius to 50 degrees Celsius is equal to, now since the specific the specific heat capacity of water is 4200, we'll multiply it with mass and the change in temperature, that is 50 degree Celsius. And when you multiply all this, you'll get 2100 joules. So 2100 joules of heat energy is required to raise the temperature of water from 0 degree Celsius to 50 degree Celsius. Therefore, the amount of heat energy required to melt 10 gram of ice will be the remaining amount of heat energy which we subtract 2100 from 5460. Okay, so 5460 is the total amount of heat energy, and 2100 joules is the amount of heat energy which is required to raise the water from 0 degrees Celsius to 50 degrees Celsius. So when you subtract this heat energy from the total heat energy, then we'll get 3360, that is 3360 joules. That amount of heat energy is required to melt 10 gram of ice. Therefore, in order to melt 1 gram of ice, the amount of heat energy required is equal to 3360 joules divided by 10, because 10 gram of ice is 3360 joules, then 1 gram of ice will be 336 joules per gram. So this 336 joules per gram becomes the specific latent heat of fusion of ice, and this is the required answer. Next is question number 4. A solid metal of mass 150 grams melts at its melting point of 800 degree Celsius by providing heat at the rate of 100 watt. The time taken for it to completely melt at the same temperature is 4 minutes. What is the specific latent heat of the metal? So, a solid melts at the melting point of 800 degrees Celsius, and the rate of flow of energy, that is, we can say the power, is 100 watt, and the time taken to completely melt at the same temperature of 800 degrees Celsius is 4 minutes. So we have to calculate the specific latent heat of the metal. So we will write down the data collected from the question. The mass is given, which is equal to 150 grams, which is equal to 0.15 kg. Here we have to convert every given units into same unit. Okay, so gram is converted in terms of kg. The melting point is given, which is equal to 800 degrees Celsius. The rate of flow of energy, that is power, is equal to 100 watt. And just before this numericals, we said that the specific latent heat of metal over here, let it be L, which will be equal to Q by M, that is heat energy divided by mass. Now, power is equal to energy by time. So, heat energy will be equal to power multiplied with time. So, power in this case is 100 watt and time is 4 minutes. So, converting 4 minutes in terms of seconds, we'll get 100 into 4 into 60 joules. So, that much amount of heat energy will be required. Now, the specific latent heat L is equal to Q by M. Let's put the value of Q as 100 into 4 into 60, and mass M is equal to 0.15 kg. So we put these values, and on further simplification we get it as 160,000 joules per kg. So writing it in the standard format, we'll get 1.6 into 10 to the power 5 joules per kg, which is the latent heat L of that particular metal. So this 1.6 into 10 to the power 5 joules per kg becomes the answer.